In this last section regarding symbolic arguments, we're going to look at drawing logical conclusions from a given set of statements. And this is a super important part of understanding logic because this is the kind of logic we use in our daily decision making. When we're looking at symbolic arguments, we're looking for a few things in general so we need to know some key words. We need to know what the premise is, what the conclusion is. We need to know when an argument is valid, and we need to know when that argument is invalid. Or sometimes we call it, when an argument is invalid, a fallacy. So when we have a symbolic argument, we're given a set of premises and we are given a conclusion, and then it's our job to figure out if our conclusion is valid. So an argument is valid when its conclusion necessarily follows from a given set of premises, and an argument is invalid or a fallacy when the conclusion does not necessarily follow from the given set of premises. Some ways we can determine whether or not an argument is valid is we can use truth tables. Or we can use some of the laws that we will go over. This next part is just a little recall situation. We want to make sure we remember which statements are logically equivalent. Sometimes it's necessary to manipulate a statement to an equivalent statement in order to better understand the argument. And so therefore we need to make sure we remember which of these are logically equivalent statements. So we have the original conditional statement, that would be if P then Q. The converse, remember, is when you flip them. So we would have Q, if Q then P. The inverse is when we have, we negate it. So not P then not Q. And then for the contrapositive, that one is when we flip and negate. So that'd be not Q, then not P. And if you recall, the ones that are equivalent are the original conditional with the contrapositive, and then the converse with the inverse. Okay. So we're going to look at some laws and standard forms of arguments to determine valid and invalid conclusions. The first law that we're going to look at to prove if an argument is valid is called the law of detachment. It's also known as modus ponens. Symbolically speaking, that is an argument that's in the form of the first premise, which I'm going to label as P1, is if P then Q, and the second premise, P2, is given as P, and then our conclusion is given as Q. And so before I go on to the other ones, I kind of want to go over why this would be a valid argument. So what we're dealing here with is we're dealing with our first premise is a conditional statement. So if P then Q, our second premise tells us that P is essentially true. And so then we're asking the question, does our conclusion follow? Is our conclusion Q true? So the way that we show this with truth tables, I think this is really interesting, is we would take both of our premises. So our first premise is if P then Q. And then with that, we combine that with a conjunction with our second premise. And then this is essentially our antecedent to a conditional statement. So this is our premise 1 and premise 2. And we're saying if these two things, then is our conclusion true? Okay, so what we want to check then is we want to check the truth table and see if we get a true statement for all possibilities, which for a conditional statement, that would be an implication. So I'm going to go ahead and write out the truth table for this conditional. If you want to pause and do it on your own and then compare, you might get some additional practice. So looking at our truth table, we see that this is an implication. So that conditional is a tautology, then we have that implication. So because of all the values, the truth values for this conditional statement here are true for all possibilities for P and Q, then therefore this is an implication, and therefore that makes that argument setup valid, and that is our law of detachment. The strength in using symbolic logic is it's representing any sort of sentence, any sort of statements P and Q. So then we just proved that for all statements P and Q, if we say our first premise is if P then Q, and our second premise is given P, then we can conclude with certainty that Q would follow from that. And so it doesn't matter what the sentences are. The sentence in the book was, if we go to the Bahamas, then we go snorkeling. And the premise 2 was, we go to the Bahamas. And the conclusion was, we will go snorkeling. So that is using the law of detachment. Another example could be, if it is sunny, then I go to the zoo. So, and then the second premise would be, it is sunny. So therefore, it would follow and be a valid conclusion and a valid argument if I say that the conclusion is I go to the zoo. So there's power and strength in using symbolic logic to show these arguments. One thing you should note, though, is that you can have a valid argument that has a false statement as the conclusion. And it's kind of mind-bending. If you look in your book at example 1, there is an example where it's the first premise is, if Canada is north of the United States, then Alaska is in Mexico. And the second premise is, Canada is north of the United States, and then therefore Alaska is in Mexico. That is a valid argument and follows the law of detachment. However, it is a false statement. So it's possible to have an invalid argument in which the conclusion is a false statement or a true statement. It's just whether or not the argument is valid is what we're looking at. So the conclusion necessarily followed from the premise. So it's not necessary for the premise or the conclusion to be true statements in an argument. It's mind-bending. So look at your book and read that a few times. Make sure you fully understand that. Because when you see a false conclusion, you automatically want to say something that isn't valid. But if it followed from a logical argument, technically it is a valid argument. The second law we're going to look at to determine valid arguments is the law of contraposition. Another name for that, again, back to the Latin, is modus tollens. I took a lot of years of Latin in high school, so this is kind of nice to see it used. Anytime I see it, I get excited. Anyway, I'm going to structure this one the way that the book does without labeling the premise 1, premise 2, and conclusion. We just say, if P, then Q is our first premise. Our second premise is not Q. And then therefore, these 3 dots in a triangle, that means therefore, not P. Okay, so again, in order to prove this with a truth table, okay, we would take the first premise, if P then Q, and the second premise, which is not Q, and then make the conditional so that we have if the combined premises with a conjunction, then the conclusion. And then we would make the truth table for that to see if it is an implication. If it is an implication and it's a tautology, then the argument is valid. If it is not an implication, then the argument would be invalid. So even one false part in the truth table would result in it being an invalid argument. Here are a couple of invalid arguments. The first one is called the fallacy of the converse. Now remember, we said that the conditional statement is equivalent to the contrapositive, but the converse is not equivalent to the original conditional statement. And so the fallacy of the converse that a lot of people want to believe is that if P then Q, and then my second premise is Q, therefore P, and this is a fallacy. This is invalid. Okay, so anytime you see something of this form, that is invalid. The fallacy of the inverse is the same idea. Remember that the inverse negates both parts of the conditional, but that is not equivalent to the original conditional. So that would be saying, an example would be if I have if P then Q, and then not P is my second premise, therefore not Q. This is not true, this is invalid. Okay, so make sure you know your laws of detachment and contraposition and also your fallacies. There are 2 additional laws of arguments in the book that you may need to know. And those are the law of syllogism, which is if P then Q is the first premise, and then we have if Q then R is our second premise, then our conclusion therefore is if P then R. And that is a law that shows a valid argument. It's also very similar to a mathematical statement or a mathematical law that we see with numbers. You might remember if A is less than B and B is less than C, then A must be less than C. That's the same kind of idea, but using conditional statements. Okay, then disjunctive syllogism is if I have the premise P or Q, and then I have the premise not P, and then we can conclude Q. And the reason why this one works is if you think about it, is we're essentially told that P or Q is true. But then they're also telling us that not P is true, which makes the original P false. So the only way that P or Q could be true, so if P or Q, if we know that P is false, then the only way this could be true is if Q must be true. And so that conclusion, therefore, would follow. Okay, if you have a disjunction and you know for a fact that one of the parts of the disjunction, sorry, if you have a disjunction and you know that one of the parts of the disjunction is false, in order for that to be true, the other part of that disjunction must be true. And again, you could set up your statement. My first premise is P or Q and not P. Does this imply Q? And you could figure out the truth table to show that that is a tautology or that it is an implication. So I'm going to run through these kind of quickly. We are going to determine which argument was applied in each of these situations, and we're going to determine is the conclusion valid or invalid. So we have if A then B, and then we have the premise not A, and then we have the conclusion not B. And so we're going to look up here and we're going to see, what does this look like? Which one of these situations does it look like? This looks like the fallacy of the inverse. So the argument was the fallacy of the inverse, because we have that negation of the premise and the negation of the conclusion. That is not valid. So we would call it invalid. Okay. The next one, if E then F is our first premise, we have E given to us as our second premise. We have the conclusion F. This is our law of detachment. Detachment. And we know that that gives us a valid argument. Now remember, we discussed that it might be valid and it also might not be a true statement when you read it, like in actual situations. Okay, we have if V, then W as our first premise. We have not W as our second premise, and then we're given not V. This is our law of contraposition. I-T-I-O-N. Okay. Because if you see here, the conclusion is what got negated, and so therefore, based on contraposition being equivalent to the conditional statement, we can get not V as a valid conclusion. This is a valid argument. If in, then O, we're given O, that gives us in. That is our fallacy of the converse. What they're giving us here is our consequent, which would kind of imply that we're looking at the converse, and so this is our fallacy of the converse, and that gives us an invalid argument. Keep wanting to spell invalid wrong. Okay, you can do the rest of these and check on your own, or email me if you have any questions on them. But again, you're just looking at the structure of the argument and determining if it's aligned to the laws that we've looked at or if it's aligned to the fallacies that we've looked at. So example 2, now it's looking at these in terms of words, and we can apply the same principle. We can also label these as P and Q and make sure, or each part of the statement is P and Q, and then figure out which one it matches with. So if we visit the zoo, so that's going to be our P. Then we see a zebra, that's our Q. We visit the zoo, so we're given P, and our conclusion is Q. That argument is our law of detachment, and it is valid. Okay. If the car, is supposed to say car, not care. If the car is a Porsche, if the car is a Porsche, we're going to call that P. Then the car is fast. We're going to call that Q. The car is fast, Q. So the car is a Porsche. That is our P. And so therefore, this is the fallacy of the converse, because our first premise is the conditional. Our second premise is our consequent. And that's the fallacy of the inverse. Sorry, converse. I said converse first. Inverse, we need that negation action. That makes this argument invalid. If Lucinda is singing in the band, so that's going to be our P, then Steve is playing the guitar. That's going to be our Q. Lucinda is not singing in the band, therefore Steve is not playing the guitar. So those are the negations, but we've negated the antecedent, which is the fallacy of the inverse. When I took logic a very, very, very long time ago, I remember our test, we had to do symbolic proofs, like really long ones. Like my final exam had a proof that was like 100 lines long. And because these are just little 3-line proofs, not even proofs, they're just arguments. But we had to do these proofs, and I remember I did mine in like 100-something lines, and my professor, I went to go talk to him after to go over my tests, and he was like, yeah, you got into a little bit of circular reasoning. He was like, you probably could have done it in just 60 lines, so I had done 40 extra lines. Anyway, I love logic. Anyway, but okay, if this is representing the fallacy of the inverse, then we have an invalid argument. Let's do a couple more of these. I don't want to go through all of them. There's a lot. If the guitar is a Les Paul model, then the guitar is made by Gibson. So that's our P. This is our Q. The guitar is not a Gibson. Therefore, we have the guitar is not a Les Paul. It's not P. This is our law of contraposition. And that makes this valid. Okay, if we go to Louisiana, then we eat crawfish. We eat crawfish. We are in Louisiana. Therefore, we are in Louisiana. That is our fallacy of the converse, which is invalid. I could do this all day. I think this is calming right now. Okay. Just a note, I keep using P and Q. I just like using P and Q because that's traditionally what you use in logic. But if you really wanted to, sometimes people like to use the letters that match the situation. So they'll say, if we go to Louisiana, that's going to be my L. Then we eat crawfish, that's going to be C. We eat crawfish, so therefore we are in Louisiana. It's the same setup. We're just using different symbols to represent the same thing. That's the beauty of symbolic logic. When we're looking at this last part, drawing valid conclusions, we're talking about this given here, and this is referring to, in all the examples that we've seen, we're looking at that premise 2. So if we're given if P then Q as our original conditional statement, and then we're given P as our premise 2, then our appropriate argument would be that law of detachment, which I'm going to abbreviate or just shorten to law of detach, and that will give me a valid conclusion. If I'm starting with if P then Q and I'm given Q as my premise 2, that's going to be our fallacy of the converse, and that's going to be invalid. So this is kind of just wrapping this general idea up of what we're looking for as our given, as our second premise. So if we have if P then Q and then we have not P, that's our fallacy of the inverse. And that's invalid. And then if I have my second premise is not Q, the negation of the conclusion, that's going to be our law of contraposition, which is a valid argument. So looking at these next examples, essentially what you're doing is you're looking at what's the second premise. And then we're figuring out what argument we're using and if it's valid or not. So we have if A then B. We're given the premise A. This is our law of detachment. Okay, and so we can conclude B. That's valid. If I have if C then D, and then I'm given as my second premise the consequent D, then the conclusion would be therefore C, but this is our fallacy of the converse, which is invalid. I almost said inverse. Oh my goodness, I'm a mess. Okay, then I have if B then C, and then my second premise is not B. That's our fallacy of the inverse. And that is invalid. But the conclusion we would come up with that would be not C. But we know that that's a fallacy that is not true. And then lastly, you have if D then E, and then we're given not E. That's our law of contraposition. And that is valid. And we end up getting not D as our conclusion. Same thing with words. Let's look at these. Determine which argument should be applied. Draw a conclusion. Is the conclusion valid or invalid? If you get too much coffee, then you get hyper. So this is going to be my if P then Q. I did not have too much coffee, so that's not P. The type of argument this is our fallacy of the inverse. The conclusion we would come up with is that I did not get hyper. But this is an invalid argument. If you get too much coffee, then you get hyper, so that's our P. If P then Q. I had too much coffee on Sunday, so that's P. And so therefore we would conclude Q, which is I got hyper on Sunday. And that would be our law of detachment. And that is a valid argument. Okay, we get the gist. I'm going to let you do those last two on your own. And that is it for this section. That's very exciting. I like symbolic arguments. Now, the book also has an argument with three premises. It's the very last example, is example 6. Okay, and if you look at it, you would do the same thing. You can make the truth table. Okay, you can make the truth table with all three premises combined together as conjunctions. So that's and statements. And then have that be the antecedent in a conditional with the conclusion as your consequent. And then you would fill out your truth table. And if you got all truths for every situation and every possibility, then you would have a tautology or an implication since it's a conditional. And then you would be able to say that you have a valid conclusion and a valid argument. If you had any falses at all, then it is not a valid argument. And then lastly, the last example in the book would be determining a logical conclusion. So they give you the premises and you determine based on those premises what is their logical conclusion. Now, and then you have to determine whether or not that's valid or not, which is what we've already been doing in these last few examples. So that is it. I know this is a long video, but this is it for our logic videos, and it was all in one instead of split up amongst 2 or 3 15-minute videos. So I'm happy. I hope you're happy. If you have any questions, please feel free to email me and let me know. Thank you.